Okay, so this is going to be part 2 to lesson 4.5, where we actually start taking some of the work we did in part 1 at finding exact values of particular angles, and then using those exact values to conduct some BEDMAS or order of operation questions. And so what we need to do here is maybe just a good practice would be to write out at the top your 3 triangles, right? Because I know I'm going to use them, all 3 of them, in some way or another. And I'm just going to rotate them around 360 degrees. So basically what we need to do here is, what is nice about part A is we don't need to worry about the signs, because in part A, everything is occurring in the all quadrant, if you remember that from the last video. So all of the trig ratios in this quadrant are going to be positive. And so what I'm going to do is just try and find the exact values of 45 for sine and cosine, and the exact value of sine of 30, and the exact value of sine 60. And I'm just going to do that with the 3 triangles that I drew at the top of my page. That might be what you choose to do on the test, right? Right off the bat, is just draw those 3 triangles, so you don't have to worry about trying to remember them when you get to that particular question. And maybe feeling a little flustered after some other questions, right? So this might be the first thing I do on a test, is just to write these out. Make sure I got the side lengths in the right spots, because that obviously makes a difference. So what I'm going to do is just evaluate each component individually and then do the math that it's asking me to do. So 45 is this triangle here, and I need the sine of 45. Well, that looks like opposite over hypotenuse, right? And so I get, for the sine of 45, and this is going to be 1 over root 2. The cosine of 45 is also 1 over root 2. I'm going to add that to, now I'm in the 30-degree triangle, that's this one over here. Sine of 30 is 1 over 2, opposite over hypotenuse, right? So I get 1/2 multiplied by the sine of 60. Oh, we're over here now. The sine of 60 is again opposite over hypotenuse. Okay, and so I get root 3 by 2. And so I'm just going to do the math here. I get 1 over root 2 times root 2 is just going to be 2, plus root 3 by 4. And so in order to add those 2 things together, I'm going to have to create a common denominator. And so I end up with 2 over 4 plus root 3 by 4, which is subsequently just going to turn into 2 plus root 3 over 4. Okay, and that'll be your answer for this expression. Okay, let's go do the next one. So the sine of 60 degrees. The sine of 60, we already know from the last question, is being root 3 by 2. Okay, so we're going to get root 3 by 2 minus, now I need the cosine of 30. The cosine of 30, I'm back on this triangle up top. Cosine this time is going to be adjacent over hypotenuse, which is going to be root 3 by 2. And then we need to divide that by the tangent of 60. The tangent of 60, I'm back over here. Oh, what happened? Pencil. The tan of 60 is back over here on this triangle, the middle one. Tangent is opposite over adjacent. So opposite over adjacent is going to be root 3 over 1 for that triangle for 60 degrees. And so not a big deal. This looks scary, but it's not a big deal. It's just fractions inside fractions. And so I'm going to get root 3 by 2 minus root 3 by 2 multiplied by, remember we got to multiply by the reciprocal, 1 over root 3. So the root 3's are going to drop out because one's in the denominator and one's in the numerator. And I'm just going to be left with root 3 over 2 minus 1 over 2. So I could just combine those because the denominators already match. I get root 3 minus 1 over 2. That should be your answer there. Okay, so those ones are not too bad. I think maybe the harder ones are going to be the second part here, where I'm actually looking for values of theta that satisfy the conditions that are ultimately embedded in these questions, right? And a little trickier to see. So it requires you to know, or at least have some idea as to which triangle is able to produce the ratios that you end up solving for here, or isolating for, I suppose, right? So in question A, not a lot of isolation to be done. Remember, you can always take something and divide it by 1, right? Now, like in the last video when I said there's a series of questions that you're going to ask yourself. There's another question that you're going to ask yourself in this particular question, which is going to help you produce the picture. And that question is, in which quadrants, this is maybe where CAST rule is going to really start to come into play and help you. In which quadrants, there's 2 of them, is tangent going to be positive? Well, tangent is going to be positive in the all quadrant, which is, so I know my triangle is going to be here, and it's also going to be positive in the tangent quadrant, obviously. And so the next question you got to ask yourself, that means it's not in these 2, right? We can ignore them. The next question you got to ask yourself is, how do I produce a ratio of 1 over 1, right? Which triangle gives me a ratio of 1 over 1? Well, if I go back up and take a look at them, it looks like the only way I could produce a ratio of 1 over 1, given the side lengths that I have on all 3 of these triangles, is with this triangle, right? And specifically the tangent of it, right? So I know if I go 1 and 1, or -1 and -1, that's the reason why both of these are positive in these quadrants. But that corresponds with 45, those side lengths, right? Those side lengths correspond with 45 degrees. And so what you can do now, if this is 0 degrees, you know theta can equal the 45 degrees that are in the first quadrant, but also all the way around here to theta can equal 225 degrees as well. Right, that'll be this one, 225. Okay, now the questions, this is the exact same thing over and over again. It's just we're going to start burying the information. You're not going to be able to identify the trig ratio right off the bat. And so that's all that's happened as we go through these questions. Not a big deal. What you can do is just isolate, right? We can add 1 to both sides. I get 2 sine theta has to equal 1. And then I can divide both sides by 2. So sine theta is going to equal 1/2. So then you ask yourself the same question, okay? Sine is positive. I don't really care about what the ratio is. I just care at the moment for the answer, for the purposes of this first question that I'm asking myself. Sine is positive. In which quadrants is sine positive? Well, I'm just going to draw my CAST rule. It looks like, sine is going to be positive here. And sine is going to be positive over here. Sorry, those aren't the same. They should be the same. Okay. Still not the same, but closer. So now you get to figure out which of the 2 triangles we're going to use. Is it going to be, or sorry, which of the 3 triangles, but we know it's not going to be the 45, right? Because I need a 2 in the denominator, which corresponds to the hypotenuse, which corresponds with sine, right? So I know that whatever this angle is, I know the trig ratio is sine, and sine is opposite over hypotenuse. So this has to be the opposite, and this has to be the hypotenuse. So I got to put 1 here and 1 there, because those are the opposite side lengths relative to my angle. And then subsequently, the 2 is the hypotenuse. So on this triangle, it looks like there's opposite There's hypotenuse. That must make this 30 degrees. And so subsequently, theta can be 30 degrees, and theta can also be the 180. If this is 0 and this is 180, we're going to go 180 minus 30, so it has to be 150 degrees. So those are your possibilities here. Okay, let's go to the next one. Root 3 should be a little clue for you. If I see a root 3, that's the 30, 60, 90 in some capacity. Okay, so again, same thing. I'm just going to get 2 sine theta has to equal root 3. Okay, and then I can divide both sides by 2. And I get sine theta has to equal root 3 by 2. So again, both positive, so draw yourself a picture. Right? Hopefully this gets easier for you the more of these you do. So draw yourself a picture. Where is sine positive? Sine is again positive in this quadrant and this quadrant. So we're going to draw our terminal arms there. And sine is again opposite over hypotenuse. So root 3 by 2, root 3 by 2. And the angle that is opposite of root 3 is going to be 60. So which makes our answer, theta is going to be 60 degrees, and theta is going to be 120. Okay, add 1 to both sides for question D. So 2 cos theta has to equal 1. Divide both sides by 2 again, so the cos of theta has to be 1/2. Whereas cosine positive, let's go answer that question first. Draw our terminal arms and then put the side lengths on. Cosine is positive in the cosine quadrant and the all quadrant, which means it's not here and it's not here. Right, so here we're going to draw our terminal arms. Okay, this should be the same triangles. Close to, as best you can. Remember, this is just a little sketch for you to be able to put the side lengths on. There we go. And they are indeed 90-degree triangles. So cosine has to be 1 over, sorry, cosine is adjacent over hypotenuse. It's a little different. So again, I see a 2 on the hypotenuse, so I know I'm at 30, 60, 90. I just don't know which of the 2 goes relative to the x-axis yet. Adjacent side length, the 1 has to be here on both triangles. And if this is my theta, right? And so, if that's the 1, that must make that 30, and subsequently this 60, which would mean that my angles would have to be 60 degrees if this was 60, and then all the way around to 360 minus 60 would be 300 degrees.
This is a reminder, if you are a homeroom teacher, to come and pick up the report card packages in the main office. Thank you.
Okay, a little bit different for question E, F, and the second F. Okay, E has some reciprocal trig ratios in it. Okay, so what we're going to do here is I'm going to just, right off the bat, I'm just going to get rid of, oh no, I don't actually for this question. I'm just going to go, I'm going to factor out a cosecant. And I'm going to be left with a cosecant theta plus 2 is equal to 0. Okay, so we get 2 scenarios here. Cosecant theta can equal 0, and cosecant theta equals -2. That's this piece here. This is just like factoring when we were solving for the x-intercepts. The problem is now, I don't really know what cosecant is, aside from the fact that it is or can be rewritten because it's a reciprocal trig ratio as 1 over sine theta has to equal 0, and 1 over sine theta has to equal -2. Okay, so here's the problem with this left side, is the 0 is going to consume the sine. And so I don't think we get any answers from that, right? We just get 1 is equal to 0, so nothing comes of that. However, on the other side, if I'm in the interest of getting sine by itself, which is what I'm after, then this is going to turn into 1 is equal to -2 sine theta. And then I could get sine by itself by dividing both sides by -2. And so I'm left with the sine of theta is going to equal -1/2. And so you ask yourself the same question as you usually do. Where is sine negative? Well, let's figure that out. Well, sine is negative here for sure. And sine is also negative over here in the cosine quadrant. And then you ask yourself, how do I produce -1/2? Well, again, sine is hypotenuse, so I have a 2 on the hypotenuse, which means I'm in the 30, 60, 90 triangle. It's just which one goes relative to the x-axis that I have to figure out. And sine is also opposite over hypotenuse. And I know the smallest angle goes opposite the smallest side length, so that has to be 30, and that has to be 30. And subsequently, our angles, if this is 0, has to be 180 plus 30, that's 210 degrees, and theta has to equal the 360 minus 30. And that's where we're at, okay, for that question. Okay, next one. Very similar from the standpoint that, yeah, very similar. So what I'm going to do here is I'm just going to factor out a sine again. Okay, I'm going to be left with something. So let's just go sine theta is going to equal 2, oops, sorry, not equal to, multiplied against 2 sine theta minus 1 is equal to 0. So we're going to get sine theta has to equal 0, and 2 sine theta minus 1 has to equal 0. And so 2 sine theta has to equal 1. Divide both sides by 2. Sine theta is equal to 1/2. So we've got two situations here. So we're going to have a bunch of spots where this is true. Sine theta 1/2. Okay, if you ask yourself, we've already done this one a few times on this lesson. Specifically right here, I actually think we did do this exact same work. So this is the same work, right? So we're going to get the same two answers. So we get, based on reasons from above, you ask yourself again, where is sine positive? You put on the side lengths. You should find from sine theta, because we already did the work, that theta should equal in this instance 30 degrees and 150. Now the new one is where is sine 0. Okay, and this is going to require a little bit more of explanation that we'll do in a later video. But it stems out of how we produced these triangles in the first place, and the idea that they were produced using the unit circle. So if I drew myself a circle, right, and I kind of drew the XY Cartesian grid on here, where this is 0, 90, 180, and 270. If this was a circle of radius 1, as we discussed when we did this the first place, that would make this point 1, 0. That would make this point 0, 1. That would make this point -1, 0. That would make this point 0, -1. And then we discussed in that lesson how we came about that x was going to equal the cosine of theta, and y was going to equal the sine of theta. Okay, all the way around here. Okay, and so the sine of theta, in this case 0 degrees, or sorry, we're looking for where sine theta is equal to 0. So the y component of this unit circle. So it looks like y is 0 at this spot, and y is also 0 over here. And so our angle for the sine of, like if we're asking ourselves the question where is sine theta equal to 0, well, we get 0 degrees, we get 180 degrees, and all the way back at 360 again. That'd be where the sine of theta is equal to 0. So again, more instruction on that later, but for right now, that's all you need to know. They're just, it comes from the unit circle and the way that we've produced these triangles in the first place, these special triangles. Okay, I'm going to need a little bit more room for question F, so just put it down here. Question F, the second question F, is a little tougher. This looks daunting, I will give you that. So what I'm going to do from the beginning of this, I'm not going to deal with the cosine. What I'm going to do here is just get rid of the cosine by saying let x represent cos theta. And so what this question is going to turn into is just going to be x squared minus 2x minus 3 is equal to 0. And that should look like something that we've done before. So I'm going to find two numbers that multiply to -3 and add to -2. That sounds like -3 and 1. And so I'm just going to go, it's a simple trinomial, so I get to go x minus 3 times x plus 1 has to equal 0. Okay, and then from here, I can just isolate for x, I suppose, but we could also, this is not too scary now to put cosine back in. Right, and I'm going to get cos theta minus 3 times cos theta plus 1 has to equal 0. Okay, and so what we can do now is both of these can equal 0. So the cos of theta minus 3 equals 0, and the cos of theta plus 1 is equal to 0. And so we get the cos of theta is equal to 3, and the cos of theta is equal to -1. So we're in a bit of a jam with this one because I think if you type this in your calculator, you're not going to get any answers. So this doesn't make any sense for that one. However, on the other one, if you ask yourself the same question as usual, where is cosine negative? Cosine is negative in the sine quadrant, and cosine is negative in the tangent quadrant. Okay, and so what we need to then ask ourselves is, how on earth could I produce a trig ratio of -1, right? Well, that sounds like, oh, how do I do that? Let's just put on some side lengths here. This is going to be -1. This is going to be 1, and that's going to be, oh sorry, -1. And that's +1. So we're in a bit of a jam here because I can't actually produce any values using the triangles per se to give me a trig ratio of -1. So this is the interesting part, right? And this kind of ties into what we just finished doing, right? Which made me think. If this was the 45, which is what I was anticipating happening, I would only be able to get a trig ratio of -1/1 had I used tangent. But I didn't use tangent for this question. And so we're in the position where we're referencing back this little circle I drew. the values or angles where the x component, so not 90, the x component is -1, right? Which is what I'm after. Not even +1, just -1. So it looks like there's only one spot that this is true for. And it's going to be where the cosine is -1. The cosine of theta can only be -1 when theta is equal to 180 degrees. That's the only time that this question becomes true. Okay, so again, I don't think the series of questions changes. You always ask yourself, where's cosine negative? Draw the picture. But then you run into the situation where maybe you can't actually produce that trig ratio using the triangles. Like this one, where you can't produce a trig ratio of -1 for cosine, right? You can only produce a trig ratio of -1 or 1 with tangent. And so that prompted me to think back to the fact that like this entire, or all these triangles have been created from this unit circle, where the unit circle has a radius of 1. And subsequently around it, we have 4 points of 1, 0, 0, 1, -1, 0, and 0, -1, where the cosine is -1 at 180 degrees, the x value. Okay, so again, more instruction to come on that in the coming lessons, but there are technically, you have 12 angles from the triangles. And then there's another 4 + 1 angles that are created from that unit circle. Okay, for a total of 17 angles that I can ask you about. And so if you know how to produce, first of all, if you can memorize all 17 of those angles, that's good, right? Don't forget there'd be like sine, cosine, tan for each of them, right? So there's 17 angles, but 17 times 3 trig ratios that I could ask you. And sorry, I didn't specify the +1 is from the 360. That's that +1. So a ton of stuff that I could ask you, but you could memorize them, or you could just understand how they were produced, right? Which is the better option, okay? It's just taking the terminal arm and spinning it around 360 degrees and stopping in each of those sections, right? Those 45, 30, and 60 areas, okay? So that's that for this, and hopefully you found the application of cast rule for this video helpful, I suppose, on the application of cast rule.